Okay, let's start. So today what we are going to do is we are going to look at question number 21, which is we have to merge two sorted list or linked list. The class structure is like this. List node is a class name. It has a value called val, which is integer value, and the next pointer. It has two constructor, overloaded constructor. First constructor which accepts only value, and second constructor which accepts value as well as the next node. Okay, so let us take a look at the question. So we are given two lists, list one and list two. List one it has three elements, 1, 2, and 4. List two has element 1, 3, and 4, and the output looks like this. If you sort, both the lists are sorted. So now if you want to merge these two lists in a sorted way, you need to have the first element as 1, uh, second element as 1, then 2, then 3, 4, and 4. Now how to solve this particular question? So the one way to solve this question is to create a new linked list itself, and just add the values based on the comparison, or you can manipulate the pointers. So let us see how we can do this in notes. Okay, so here are two sorted lists. Okay, list 1 has values 1, 3, and 5. List 2 has 2, 4, and 6. Result is 1, 2, 3, 4, 5, 6. All right, now if you want to merge this list, uh, what you can do is you can just play with the pointers. Okay, and how to do that? So let me just explain you how you can play with the pointers and get the results, and I will implement the solution for that. So so how you can do that is, let's say you have this list. Let me just use the black color and erase this thing, and black color. All right. Okay, so let's say first list is 1, 3, and 5. Second list is 2, 4, and 6. Assume that you have a dummy node. Okay, this is dummy node. Okay, and what you can do is you can just point the first element, whichever is smaller of these two. Okay, so let's assume that we have written the code and you can point it over here. Okay, it might be better if I use different color over here. Okay, so you can point it to 1. Okay, now if that is the case, then this second element should be 2. You can point it like this, so this will go away. This won't be the case anymore. From 2 you can point it to 3. This won't be the case anymore. From 3 you can point it to 4. From 4 you can point it to 5, and from 5 you can point to 6. Now this looks all simple and catchy, that okay, yeah, this will work on paper, but will it work in the code? So let us see how this will work. And we will also see a use case where one list is longer than another list. So let's say that you are given a list as like this, 15 and 20, and another list is 8 and 9. Okay, so this list will have three additional elements. So how to calculate that, how to merge that? So let me tell you how to do, how to solve both of these problems. So let's say we have a method called as list node, and method is merge list. Merge list and list node L1 and list node L2. Okay, so let us just create a dummy pointer and call it as result. So list node result equal to new list node. Okay, we have this constructor that initializes value to 0 and next pointer as null. So this is just a dummy thing that we are using, and I will tell you why we need this one. Okay, and let us use a pointer to navigate this result. So we can also say this thing as pointer result. Okay, now we have to uh, iterate through this list in such a way that the length of both the list at the end of both, we have to iterate in such a way that the shorter list completes first. So let's say we iterate this list over here 1 8, and then we iterate for 2 and 9, assume that, and this thing is pointing to null. So as soon as this points to null, we know that this other list will already be sorted. So we don't need to do anything. We just have to point it over here from 9 to 10. Okay. So how to do that? So we write this thing while not equal to null and n L2 is not equal to null. Okay. That's it. Now let me just change this color. If L1 dot val is less than L2 dot val value, if that is the case, then what we have to do is we just not swap, but we just manipulate the pointer. So how to do that? We have this pointer, right? So we say pointer dot next is equal to L1. Okay, and then pointer is equal to pointer dot next, and L1 is equal to L1 dot next. Sorry about that. Isn't a method. Okay, if L1 is less than L2, then what we do is we take this pointer. So for example, this guy over here, this is L1. Okay, and this is L2. So pointer, and this will be, this pointer is pointing over here, pointer P. So this is the dummy node, and we will be pointing P over here. L1 is over here, and L2 is over here. So if that is, if L1's first value is less than the first value of list 2, then we just move the pointer dot, we just point this next value over here to L1. We just move the pointer over here now. So pointer will be pointing over here, and L1 is equal to L1 dot next. So now L1 will be pointing over here to the second value, because now we will be moving forward and checking for the second value. Else we know that if this is not true, then we have to take the value from the second list. So we can say like this: pointer dot next is equal to L2, pointer is equal to pointer dot next, and L2 is equal to L2 dot next. All right, and that is how we will complete this while loop. Now this is important. What if this particular list is list 1 and this is list 2? This list is longer, right? So how can we solve this problem? What we do is we can say that pointer dot next is equal to, if list 1 is not equal to null, which means if there is elements still exist in list 1, then attach that list, else attach list 2, and you just return this main result pointer, result object dot next. That's it. Okay, this is important line. If two lists are of different sizes, then this line becomes really very important. And this AND operation over here will guarantee us that either of the list will be empty. That's why over here we can go ahead and with the assumption that one list will always be empty. The time complexity of this algorithm would be, uh, time will be, on worst case, will be of n plus m, which is n plus m, where n is list 1 size and m is list 2 size, and space complexity is of 1, as we are just using these two pointers, and that's it. We are not using any additional space. Let's take a look at this solution in Leetcode. Alright, so let us start coding this method. Let me just change this color so it is visible to everyone. Okay, just give me a second. All right. So let us take our code and just jolt it down. So we just create a dummy pointer list node, and list node pointer is equal to result, and we will iterate till both the list, either of the list is empty. L2 is not equal to null, and if L1 dot well is less than L2 dot well, then pointer dot next is equal to L1. Move the pointer ahead and move the first list ahead also. Else we have to take the value from L2, pointer dot next equal to L2, pointer is equal to pointer dot next, L2 is equal to L2 dot next, and if either of the list is longer, then we make sure that that is also attached. Return result dot next. Just let me verify quickly if there are any typos. Result pointer, if both of them are not null and first is less than second, L1, pointer next, L2. Okay, let's see if this works. It's a bit. Okay, so this is how we can merge two linked lists. Thank you.